Okay, here we go for geometry, section 8.1, ratio and proportion. A ratio is a comparison between two quantities. This vocabulary words here, ratio and proportion, should sound very familiar to you, but we just want to iron out a couple of things and make sure you have the formal definitions here. A ratio is that comparison between two quantities. So what I'd like you to do is we are going to compare the number of left-handed students in this room to the number of right-handed students. We're going to compare the number of left-handed students to the number of right-handed students. All right, Mrs. Walker and I spoke this evening, and we believe that there are 6 left-handed students in the classroom, and there are a total of 30 students in the class. So if we have 6 lefties, 6 left-handed, compared to 30 total in the class, means there are 24 right-handed. Okay, now I've put some labels on here, but if we talk about a ratio, then since we're talking about students here, we have the same units, so we can write this ratio of 6 over 24 this way as a fraction, or we can write that like this, 6 with a colon 24, and we read that as 6 to 24. Or we can actually write out the word 2 and write it this way, 6 to 24. Either of those or any of those 3 ways is valid to express a ratio. Very often, though, we want to look at our ratios in simplest form or reduced form. Simplest form or reduced form. So looking at this fraction, 6 over 24, we could rewrite that or simplify that fraction down to be 1/4. So we would be looking at this ratio in simplest form as 1/4. But likewise, this 6 to 24 over here, we would write it as 1 to 4. And this one over here with the word TO, 4. When we show this simplest form, and when I wrote this equation over here, I actually wrote a proportion. A proportion is a statement showing that 2 ratios are equal. Proportion is a statement showing that 2 ratios are equal. So this whole thing right here is a proportion that shows 6 to 24 is equal to 1/4. Those 2 ratios are equal. There are some properties of proportions that we need to take a look at. If, in general, we say we have this proportion, A over B equals C over D, then we can say A times D equals B times C. And how did I get that? I just cross multiplied. So this statement right here, A times D equals B times C, says that the cross products are equal. Another property is if we just do the reciprocal of each side of this proportion here. So if we flip over the left side, that becomes B over A. And if we flip over the right side, that becomes D over C. Notice when we cross multiply here, B times C equals A times D. We have exactly the same cross products. Also, instead of just flipping these, instead of going A over B equals C over D, we can go across. And we could rewrite this as A over C equals B over D. And again, notice we have the same cross products. A times D equals B times C. So I'd like you to see that this statement, this one, and this one all have the same cross products. All right, there's one more property, and it's not as easy to see as these guys. If we take a look at that property, here's what it says. A plus B over B equals C plus D over D. So first I want you to look at what I did to get from this side right here, this left side, A over B, A plus B over B. So what I did is I took this denominator and I added it to the top and kept the denominator the same. Same thing on this side. Took this denominator, added it to the top, and kept that denominator the same. Now that's the pattern, but here's why it works. If we start off with this proportion, A over B equals C over D, and if I go ahead and take this equation and add 1 to both sides, A over B plus 1 equals C over D plus 1. That's legal. I can add 1 to both sides of an equation. Now, I just got to erase that. It looks ugly. There we go. That's a little better. Let's get a common denominator. So this 1 here would be B over B. So we have A plus B over, oops, I better not write it that way. I better write it separate for you. Let's write this as A over B plus, and this 1 is B over B. And on the right side, C over D plus 1, let's write that as D over D. Now we have common denominator on the left side. Common denominator is B, so we can add the numerators. A plus B over B. Right side, we have a common denominator of a D, so we can add the numerators. C plus D. And there we go. That's why that pattern works. If this kind of bothers you, that's all right. Mostly what I need you to do out of this is I need you to recognize this pattern. All right, let's flip over and look at page 2. Just looking at some examples here. If x over y is equal to 4 over 7, then what about y over x? x over y is 4 over 7, then y over x. So notice we just flipped the left side, so we'll have to flip the right side. And that's just 7 over 4. How about this next one? X over 4 equals. So same starter, x over 4. Look what we did. We went across this time, x over 4. So this one's going to have to be then y over 7. Same direction, y over 7. All right, how about this one? 7 over y. So look what I did in the original. I started here in the bottom, 7, and I went 7 over y. So that's going to have to match up with 4 over x. Notice, in all three of these cases, if you cross multiply, this gives us 4y equals 7x. Up here, 7x equals 4y. Down here, cross multiply, 7x equals 4y. Same thing here, 7x equals 4y. We have the same cross products all the time. That's important. All right, how about this one? X plus y over y. This is that last property that I showed you at the bottom of page 1. So look what we did to the left-hand side from here. X over y. We took this denominator and added it to the top, made it x plus y, and kept that denominator the same. So following that same pattern on the right, we're going to have to take this 7 and add it to the top. So this will be 4 plus 7, and keep the denominator the same, 7. We would simplify that absolutely down to x plus y over y is 11 over 7. All right, now look at this one, 4 over 4 plus 7. Look at the pattern. So that's this 4 and this 7 side. You see we kept the numerator the same? We kept the numerator the same, and then in the denominator, we just added that numerator down to the denominator. So let's follow that same pattern on the right-hand side. Notice we keep the numerator the same, so that's got to be x. And then the denominator, just like we did over here, we added 4 plus 7, so we added these two, so we're going to have to add these two here, x plus y. And there we go. All right, now bringing back some algebra, this should all be review for you. In order to solve a proportion, we need to cross multiply. So we can cross multiply here and do 5 times x. 5x equals 2 times 35, 70. Divide out that 5. X is 14. Done. All right, look at number 3 right here. Solving this one. Again, cross multiply. 6 times 4x. 24x equals 9 times 8. 72. Then divide this out, and if you don't know what 72 divided by 24 is off the top of your head, that's fine. Don't reach for your calculator. Just write this as a fraction. 72 divided by 24. Now see if you can find something that goes into 24 and 72. How about 8? We could divide this 72 by an 8, which would make that a 9. Divide this 24 by an 8, which makes this a 3. So now we're looking at 9 over 3, and you should know that one. That is 3. Okay, looking at this next one. Again, cross multiply. Be very careful here when you have this quantity of x plus 1 though, because this 2 has to be multiplied by all of that. So take the time to write this out. 2 times x plus 1 equals 3x. Distribute that 2 through. 2x plus a 2 equals a 3x. Subtract the 2x from both sides, and we get x equals 2. Done. That wasn't so bad. Look at number 5 over here. Again, cross multiply. Don't forget to write this out as 10 times the quantity 4x minus 3 equals a 5x. Distribute that 10 through, and we'll have 40x minus 30 equals a 5x. I'm going to subtract the 40x from both sides. That'll give us a negative 30 is negative 35x. Again, you don't need a calculator for this. Just divide both sides by negative 35 and write the fraction. So x is negative 30 divided by negative 35. Simplify this. Well, the negatives are going to turn that to answer to positive. And then can you find something that goes into 30 and 35 evenly? Yep, 5. So this simplifies down to be a positive 6/7. And that's it right there. Done. That should look very familiar to you from algebra in terms of that cross multiplying to solve that. Now, a few word problems here. Ratios and proportions are used very often in maps and scale models of things. So we have the Leaning Tower of Pisa in Italy, which is 185 feet tall. A model of that Leaning Tower is 6 inches. What is the ratio of the height of the model to the height of the real tower? So, ratio, single fraction. It's just a single fraction is that ratio. And I always jot down what order I'm looking at this. I want the ratio of the model to the tower, or to the real thing. So I'm going to write this down as the model to the real thing. So I'm going to set up my numbers that way. And let's see, the model is 6 inches. And the real thing is 185 feet. All right, now we have a problem. Because in a ratio, the units must be the same. In a ratio, the units must match. So we need to either turn inches into feet or turn 185 feet into inches. It makes no difference which way you go. Personally, I probably would change this 6 inches into half a foot. So instead of 6 inches over 185 feet, I'm going to have 1/2 foot over 185 feet. Those units now cancel because they're the same, so those units divide out. And we have 1/2 over 185. And the way we can simplify that, we don't want complex fractions, is if you just multiply by this 2. If we multiply by 2 over 2, then 1/2 times 2 is 1, and 185 times 2 is 370. That's the ratio. And notice there are no units on a ratio. Because they canceled each other out because they were the same. Alright, the next one, let's look at number 7. A map has a scale of 1 inch equals 40 miles. On the map, the distance between two cities is 2 3/4 inches. About how far apart are the cities? So again, when I set these up, I am going to kind of write down what order I'm doing these in. A map has a scale of 1 inch to 40 miles. So the map So the real thing is 1 inch to 40 miles. Now, we're going to set up a proportion here, and a proportion does not have to have the same units. So we can leave it this way, 1 inch to 40 miles, and this has to equal, or we want to figure out the distance between two cities is 2 3/4 inches. Well, that's on the map, so that 2 3/4 inches goes up here. And we want to find out the number of miles, x miles. So again, units don't have to be exactly the same in a proportion. This equation is a proportion, but they do have to match up. So inches to inches, miles to miles. But in a proportion, they didn't just have to match, they had to be exactly the same. So maybe I should go back and take out this word match here and say must be exactly the same. And in this proportion down here, the units just have to match up. So inches to inches, miles to miles. All right, we need to solve this. Oh boy, let's cross multiply. Since our units are matching, we don't need to worry about them, and we'll just cross multiply. 1 times x is x, and now we need to do 40 times 2 3/4, and you can do this without a calculator because you can do 40 times the 2. 40 times 2 is 80. Now do 3/4 of 40. So 3/4 of 40 . 3/4 of 40 is 30. So we had 80 plus 30, 110. That's x. So the cities are 110 miles apart. Okay. Please do section 8.1 homework. Do section 8.1 homework that is due on the next day of class, which for you is Monday. Thank you very much. Oh, I forgot to tell you, for 22 through 24, you will need an inch ruler. Okay, hopefully you have one at home. If not, maybe you can get this printed during study hall today, and then you can use a ruler during your study hall. Thanks.